graphical representation of motion. Graphically, motion can be represented in two ways. It is in the form of a distance time graph, where we calculate the speed of an object with the help of distance and time that is given to us. Whereas in the velocity time graph, we calculate the distance of the object with the help of velocity and time that is given to us. This is a distance time graph for an object which is moving with uniform speed. And what is uniform speed? When an object covers equal distance in equal intervals of time, then the object is said to be moving with uniform speed. So here in the graph you can see that distance is taken along the y-axis and time is taken along the x-axis. So in 5 seconds the object has covered 10 meters, in 10 seconds 20 meters, in 15 seconds 30 meters, and so on. So here the distance is increasing at a uniform rate. Now here you can see that as this is a graph which is showing uniform speed, the graph of distance travelled against time is a straight line which is passing through the origin. Now if I want to calculate the speed of the object, then this can be done by taking any 2 points on the graph. Say we take points A and point B. Now if you see the coordinates of point A, on the x-axis the coordinate of point A is 5 and on the y-axis it is 10, so 5 and 10. So here we take x1 and y1. If you take the coordinates of point B, on the x-axis the coordinate of point B is 10 and on the y-axis it is 20. So if we calculate the slope of the graph, what is slope? Slope is equal to y2 minus y1 upon x2 minus x1. y2 minus y1. What is y2 here? What are the y coordinates? 20 and 10. So 20 minus 10 upon x2 minus x1, that is 10 minus 5. So 20 minus 10 upon 10 minus 5 will give us 10 by 5, which is equal to 2 meters per second. So the speed of the object which is moving with uniform speed in this case is 2 meters per second. This is a distance time graph for an object which is moving with non-uniform speed. Once again, the time is taken on x-axis and distance is taken on the y-axis. Now since the object is covering unequal distance in equal intervals of time, we find that the nature of the graph is a curved line. This is a velocity time graph for an object which is moving with uniform velocity. Here you can see that the velocity is shown on the y-axis and the time is plotted along the x-axis. Now if the object is moving with uniform velocity, we find that the height of the object is not changing with time. So this is the height of the object. Okay, we have taken 2 points A and B on the graph, and if we are drawing perpendiculars from point A and B, the height will be AC as well as BD. So the height of the object is not changing. Also, the graph that we draw will be a straight line which will be parallel to the x-axis. So this is the graph which will be parallel to the x-axis. Now if we want to calculate the distance that is covered by the object, in this case the distance covered by the object will be enclosed within the quadrilateral, the area of the quadrilateral ABDC. So if we find out the area of the quadrilateral ABDC, we will get the distance that is covered by the object. Now we know that speed is equal to distance upon time. So speed is represented by V is equal to distance is S upon time. So if I want to calculate distance, S will be is equal to speed into time. Now what is the speed? Speed is equal to the height of the object, that is AC or BD, and AC or BD is equal to 20 kilometers per hour. Into what is the time here? The time can be calculated by taking the difference between these two coordinates, that is T2 minus T1, that is 15 minus 5, which is equal to 10 hours. So if I multiply the length with the breadth, that is 20 kilometers per hour into 10 hours, what I get is S, that is distance. So in this case, S will be is equal to AC into CD, 20 kilometer per hour into 10 hours. So S will be is equal to 200 kilometers. This is a velocity time graph, and this velocity time graph is the graph of a body which is moving with uniform acceleration. Here you can see that the time is taken on the x-axis and velocity is taken on the y-axis. A velocity time graph always helps us to calculate distance. So how will I get the distance that is covered by the object? The distance S that is covered by the object is enclosed within the quadrilateral A, B, C, D, E. So if I find out the area of quadrilateral A, B, C, D, E, I will get the distance that is covered by the object. So how can I calculate this S? S is equal to area of rectangle ABCD plus area of right angle triangle EDA. So by adding up the area of rectangle and area of triangle, I will get the distance that is covered by the object. The first one is a velocity time graph, where we can see that the velocity of the object is decreasing with time. So once again, this graph is a straight line, but it has a decreasing slope. Okay, here the velocity decreases by equal amounts in equal intervals of time. The one on the right hand side is a velocity time graph for an object which is moving with non-uniform acceleration. So you will find that there is a change in velocity with respect to time. Therefore, you will find that the graph is showing a lot of variations.